So welcome everybody. This is our office hours, and we have it on the third Wednesday every month. And this session is recorded. If you don't feel comfortable with the camera, you can just turn off, and because we are going to release this recording later as part of our YouTube channel. So that's perfectly fine if you don't want to be hearing. Generally, only the person that is speaking is being recorded, so no worries about it. And yeah, and we have that's only we are the master of ceremony here. You can skip this one. This is just empty. So we have Chris, and want to say a few words, Chris?
I think most people here know me. Developer advocate at Timescale. I'm in Germany, so for the people close to me, closer to me than to Jonatas. And we also have Jonatas.
Yay. So yeah, I am Brazil. I live in this city named Paradise in Portuguese. So I live in the Paradise, and that's the most common joke for me. And we also have today Yanis and Kirk, and we also have Andrew, and we are going to talk just about the latest release, and then Yanis will take over and talk about mutable compression. And if anyone has any question and anything, we can go for it later, and we can be clarifying any questions. So we have this 2.11 release in the previous weeks. So this is the newest one, and we have a lot of things there. So especially this new support for compressed chunks. I think that's the thing that Yanis will be talking about, and the support for joining hierarchical continuous aggregates are very let's say new kind of features. And then we have a lot of bug fixes. So if you can go to the next slide, you see that we have a lot of things going on, and small and big stuff there. So we are not going to go over all of them, and we are going to just give the space for Yanis, as he is bringing the news about this new feature everybody is looking for. So I guess that's all from our side. Yanis, if you want to take the screen and share your screen. Yeah.
Thank you. Thank you. You can ask me any question you want. I'm Yanis. I'm the product manager for the core database. So that means we work on hypertables, compression, continuous aggregates, policies, and I'm also the product manager for data tiering. So any questions you have, please bring them on. I can also discuss about joins and continuous aggregates later on. But we thought that because the very big update that a lot of people most voted feature request is about what we call mutable compression. So we thought of doing a full session. I'm going to go deep on you. I don't know, Chris, and if you agree, I can go and do the full presentation if you want on how compression works, and then we can discuss everything else. Please feel free to stop me. I'm terribly ashamed, and I want to ask a big sorry. I used the old slides for our old slides, so the colors are not matching what they should be matching. I'm really, really deeply sorry. Hopefully.
Problem.
Yeah, so mutable compression. Let's get started. The first and most important thing, why compression matters. So one thing is that we can reduce cost, and compression is really good at this by definition. And if you set your segment bias correctly, and depending on your data set and the nature of your data, you can go to 90–95% compression rates. But it's also very good on providing better performance, faster queries. This is very important. A lot of people forget about that on compression. Compression can improve performance as well. So there is this very interesting thing where you save on space, but also can make your queries faster but there is a big asterisk there. Don't forget your segment bias. The most important thing for compression in general is the segment by and your order by, but the segment by especially, if it is relevant for your workload, it can speed up your queries a lot, and we can discuss it later on if you want. So why mutable compression is important? So mutable compression, the main blocker for adopting compression was the ability to update or delete data after the chunk is compressed. This was a very big problem. A lot of timescale users were having that. You could, of course, compress, decompress, make your updates and recompress, but it was a little bit difficult. Of course, if things will come out of order, for example, if you have a pipeline using Kafka or whatever, and something that was compressed resulted on an update on a compressed chunk will fail, or a double insert on a compressed chunk will cause issues. So mutable compression removes this blocker, and we call it mutable because before it was immutable. You cannot update anything. The more important thing from my point of view here is we don't only enable updating, deleting, and all those DML commands, manipulation of data inside compressed chunks, is that it repositions compression as an integral part of our storage architecture. So now the way we look at storage architecture from our point of view is that now this is a continuum where compression is no more a feature to be used in some use cases, but a part of the data lifecycle in Timescale in general. There will always be some use cases where you may not want some edge cases or some very specific types of workloads where you may not want to have compression. But with mutable compression now, you can extend your architecture and have a big part of your data compressed. So what has happened? We have started, in general, we have re-architectured the compression. We have revisited the way we do compression. We did a silent update in 2.10 where we introduced this re-architecture, which resulted in faster and more simple inserts, more simply on our side. And that the result for anyone using Timescale is that since 2.10, inserts on compressed chunks are 2 times faster than they were before 2.10. And this is a direct result of this new architecture. And of course, we went all in with 2.11 and we released the mutable compression. And what does it mean? It means that you can do updates, deletes, upserts, on config do update, and of course, on config do nothing. I have 2 small asterisks there that we can discuss, that if you want to have an existing compressed table and you want to enable upserts and conflict, in general conflicts, because you have to add those unique constraints, you have to recompress, but we can discuss it a little bit in a while. So I have a lot of people telling me that they love compression and they want more details. So I decided to do a full chronological overview of compression. Stop me if you don't like it. And I will go back to Timescale 1.5. Compression more or less works the same right now. I wanted to go over it, but because a lot of people are like, what happens behind the scene? This is a normal table. This is a chunk that is ready to be compressed. It's in the way we look at the relations to relational databases and in Postgres and Timescale, of course. It has a timestamp, a device ID, a status code, etc. What do we do when we compress? We bundle things. First of all, we decide that we'll compress a full chunk. All our operations are at the chunk level, for most operations in Timescale in general are at a chunk level. And we say we're going to compress that chunk. What are we doing there? We take bundles, batches of up to 1,000 records, and we batch them together. And then we start compressing every single column inside that batch together. Why do we compress every single column? Because that allows us to apply specific and optimal compression algorithms for each data type. So for example, we do gorilla compression for floats, or we do dictionary compression when we don't have anything else, or we have low cardinality characters, etc. And of course, we do delta of data that together with all the other tricks in the book for integers and timestamps, which is one of the best ways to compress things. So the idea here, if you look at it, is that we switch when we do that to from row level to vertical to those are compressed and stored each column by on its own. So how are things actually compressed? So you have this compressed table. Please stop me if you have any questions. I'm talking about stuff. So we have those compressed things. We call them each bundle of things. We call them a compressed tuple. As I told you, there are up to 1,000 tuples, records there. And we have what we call the segment by and the order by volumes, in addition to everything else. And what's the important thing there? Okay, first of all, the segment by. The segment by is important first for compression and also for queries, because instead of going chronologically by timestamp ascending or whatever, or descending, and fetching 1,000 rows at a time, by setting up a segment by, you drive how to bundle things. So you give us a hint and you tell us bundle things based on the ID. And that means that we will group things from the same device inside this chunk together. And why is this important? It results in great compression rates, because, for example, temperatures from the same device will be similar, or whatever other metric you have. So instead of having various different temperatures based on time, so you have a big variation. If you go by device, those things here will be very similar and allow us to compress way further than we will do if we compress all temperatures together. And why is this good for querying? Because the segment by is uncompressed. So if you filter by, you group by the segment by, we go in there and we know which tuples to fetch without decompressing anything. So this is the part where we speed up. And also the order by, which by default is the timestamp, it's time. We also keep a mean and max of the order by. That also helps us with the queries. So this is a conceptual view of how things are after we compress them. And it allows us to have great compression results and also speed up queries. As I told you, compressed and compressed, and this is a batch. So after that, time passed. At the Timescale 2.3, we also introduced inserts. And the trick back in the day before 2.3, for you that joined us after 2.3, we did not have inserts in compression. It was a fully new thing. And what we did there, we thought that, yeah, okay, we want to insert, but you cannot insert inside a compressed thing. You have to decompress it, or you may have already have 1,000 things sitting there. It will be expensive. So the trick we did from 2.3 to 2.9 was that we said, okay, we're going to support inserts. They will be a little bit slower. And what we have been doing is that each single insert that you are doing, we will take it and add it as a compressed tuple by itself. One thing there in the end of the table. And that allowed us to support inserts. Of course, as you can imagine, that is suboptimal from a performance, because you have to take the hit to compress something, add the headers, etc. But so, of course, also suboptimal from a compression rate, because you cannot compress a value further than what you have. So in reality, when you insert from 2.3 to 2.9 for a while, things take more space, because for this tuple, we add also the compression headers. It is a small overhead, but in reality, when that insert happens, we expand the space. Of course, later on, what we do, we add those individual rows as we insert, and then at the end, we go asynchronously and recompress everything, so we save that space. And this is how things were working up to 2.9. So as a recap, today we have this thing, we have compressions. Compression is all or nothing. It's always at the chunk level. And before mutable compression, what you had to do if you wanted, for example, to backfill data, or you had a few updates, you wanted to do something with your data, you had this compressed chunk that sometime in the past it was compressed. Maybe it was compressed manually or through a policy. And then you wanted to backfill or update. You had to pause policies decompress and compress the chunk. You work with the decompressed data, uncompressed data. I always confuse the un with the uncompressed data. And then later compress again and enable the compression policy. So that was the whole overhead that we had to do before 2.10. So what is the architecture that we did? And I'm going to start with 2.10, but it's the same on 2.11. The idea here is that for each compressed chunk, we introduced a staging area. So we introduce an uncompressed chunk next to the compressed chunk. And what we're doing, for example, when you insert, in reality, we insert into this uncompressed, into this staging area. That's why, as I said, that inserts are 2 times faster. Inserts are like inserting into an uncompressed chunk. Because in reality, what we are doing in the background is that we are inserting in a normal table, but we are doing this transparently. So we let all inserts go in there. Of course, our queries go to both the compressed and the uncompressed chunk. If we're lucky enough to find it here, it will be also very fast. And then, of course, later on the background, through our recompression policy, our compression policies, we go back and recompress and move that whatever number of tuples you have inserted and move them to the compressed chunk area. But that happens asynchronously in the background without blocking any inserts or slowing the inserts and in general affect the ingestion rate. 2.11. Now I guess that you know what happens with 2.11 now that I showed you everything I've showed you. When an update comes, we know that this update has to update this tuple. We find it. This means this is the paths with 1,000 tuples that we take it, compress it, and make the update. This step is somewhat expensive, but it's not hugely expensive if you have to decompress just one chunk. There is some type of an overhead for this update, but if you have a lot of updates for this bundle of stuff, everything else will come for free. So what we do is we find it, move it, decompress it here, update, and then also later on recompress asynchronously in the background and move everything back to compressed chunks. Delete, upsearch, and
can I ask a question?
Yeah.
So the staging area is like let's say dumping out the lines that are already available there. Let's say I used one line from the compressed chunk, and then now I have 1,000 lines in the staging area. And then, like, if I update like 10 lines of this, like it will update the staging area in 10 different points, let's say.
Yeah. So here, if you, instead of having to update this line, you have to update all those lines. You only take the hit of decompressing once, and everything will be there, and you will be working on an uncompressed table. And we bring things as required from right to left.
Okay, and so if we have more lines, it will just create 2 batches, for example.
Well, however many lines you need to decompress. And this is something that I'm going to mention later on some tricks. But if you think about it, and that's back to using the order by and the segment by correctly, let's say that I wanted to backfill now. If I go in order of the segment by and the order by, I touch each of those in order. So, I'm touching this, I'm decompressing, updating everything here, going to the next. Of course, there is a delay on the compressing, but there are things that you can do. You could manually execute the recompression step. You could fine-tune the job that we're doing on the policy or the compression policy to run more often. This is always a balance, a performance balance between how many data you want to keep on the staging area, how often you want to recompress, because sometimes you don't want to recompress if you have a few lines. But at the same time, if you were doing a huge backfill, that means that you have a space expansion, for example, because you are decompressing. So there is an incentive to go back and recompress. At the moment, as with everything else, we keep this open. We have the way our policies work, but of course, anyone can fine-tune the job to run as open as they want. Yeah, so boring. I have to give a TLDR. I went very history maniac. So kind reminders. I want to go back to the beginnings of compression. Please remember, be aware of data types when using compression. It depends on compression depends on the compression algorithms. We cannot compress everything equally in an equally good percentage. So, for example, a great example is using float versus unbounded, decimal numbers. We are very good with the 𝗥𝗲𝗃 compression when compressing floats. But if you want to add, decimal numbers with 15, numbers after the dot, we are not that good, as you can expect. So if you don't need the additional decimal places, using floats will be a huge increase in compression rate and everything. Same for some other things. We don't fully support numeric, or JSONB. Our internal algorithm, the default algorithms for doing those can be pretty good. I have had discussions with users that were using JSONB and were very happy. They were getting pretty great compression rates. But this is not true for everything. So, be careful. It's always better to use integers and things that we can cover. If you check our documentation, we have exactly the supported data types. The second advice, please be careful of your segment by. If you don't know enough about segment bias, go and check it. This is the most important tool we have with compression. It can make a huge difference. It affects compression rates, it affects query performance, and this also affects what is compressed and compressed while we are doing operations, because as I showed you, we're doing this tupling. If you are doing a segment by, it allows you to just pick the tuples that are relevant. And I'm going to talk about this more. One thing to remember, and I hope showing it explained it, when we're doing mutable compression, because we're moving data to the staging area, you will have some temporary increase in disk usage. If you have just random small number of updates, it's okay. If you are expecting to do a number of updates, then you have to be a little bit more careful and know about this. There is nothing we can do. We cannot beat nature here. If we want to update something that is compressed, we have to decompress it. But you can fine-tune how often we decompress so that you can compress way faster. Use the segment by. Yeah.
Could I ask a question? Just
of course, Daniel.
Yeah, thank you. I just had a question regarding, you mentioned float types as opposed to using decimal data types for improved compression. So I suppose when you say float, you mean the double precision data type that is kind of the default or the usual type in Postgres, or is there a need to use the float like the 32-bit floats, IEEE floats, or are there any constraints like that?
It should be both floats. It's just that you don't want to use numeric or the unbounded decimal type, because that can be arbitrarily large.
Yeah, I see. Okay. Thanks.
We have somewhere in the documentation a full cover. We fully cover exactly the types that support and don't support. I cannot see it right now. I'm not good at searching for things.
I'll find it.
I can give it a go as well, just to have a little bit.
Yeah, I think that Chris is way better than me. I'm very used to using databases to search for things. That's why I'm used for a living. So yeah,
SQL doesn't work on the web, right?
It would be very nice.
Yes.
Fully declarative browsing.
Just to connect to kind of a comment and question there regarding the docs, I'm quite new to Timescale and I love it so far. And I've used these kind of getting started sections just to get going with compression and everything, and it's awesome. But you emphasize really a lot that segment by is extremely important to get the compression rate you want, etc. But that's not very clear in the kind of the docs from what I have seen. It says how, it describes how to do to enable the policy, etc. But it doesn't really push for using the segment by property. So
yeah,
maybe
I agree, and it's on my list as one of the best practices. More intensive blog posts, anything compression.
I think that we should do both a blog post and move as whatever I just discussed. We should have them inside the docs. Thank you, Daniel. I think this is very useful for me. We should go back and add this because segment by is the most important thing ever.
Yeah, I realize that now. And I think you sent a link, Chris, on Slack to the API description, and of course it's available there, but it didn't say anything in the kind of introductory sections about compression.
Yeah, thank you.
That makes sense.
We should make a blog post and also work with Gina to but a big thing there. I think we should think about this. Thank you.
Yeah, no worries. And while I'm at it, when already interrupted you, just a question about the segment by. Is there a limit on the number of dimension you can segment by, or is it like you can have a number of columns that you use segment by on?
There is no limit in theory, but as always, you don't want to go below 1,000.
So the 1,000 elements per batch. So the idea is that when we compress stuff, we take multiple rows and compress them in batches. So if you have like 1 million rows and we make batches of 1,000, you end up with like, what is it, 100 batches or something, or 1,000 batches per compressed chunk. What Yannis meant is you don't want to get too far or too low in this 1,000 batches. So you don't want to have so many segment by columns or dimensions that your batches go down to like 10 elements per row, because then you don't get like good compression. Right.
So you segment the million rows into like 100,000 bunches of 10 rows each, and that's
right. Exactly. And then you get much less compression, obviously.
Right. I understand.
Very few rows as a median to have around 1,000. We don't want to go way away for its combination. For example, a mistake a lot of us have done during initial testing of Timescale was to set segment by the time as the segment by, or something that is a unique column. What does it mean? It means that you only have one record per batch, per compress. So you compress its record by itself, and you end up with more space. Needing more space because you have the overhead.
Some overhead.
So the sweet number is that, and this is true in general with segment buys, but this is true also for partitioning, if you want me to go there. So you don't want, when you do this thing where we chunk things, either here in compression, we chunk inside the chunk in those batches, when you don't want to go below 1,000. And also, when you are chunking your partition, you don't want your partitions to become too small. A lot of people go trigger happy when you realize that you can add as many dimensions as you want. You can go trigger happy and add so many dimensions that each partition is so small that it makes no sense. So, for example, for partitions, you don't want them to be, you want them to be small so that everything can be cast in memory. Your index is everything, and this is at the core of our ideas in Timescale. You don't want them to be like 1 megabyte. No reason. If you can go bigger, and the same is here for compression. So you can do as many combinations as you want, as long as you make sure that it, for your use case, it makes sense.
Yeah.
And also, I will also remind everyone that it also relates to the way you query. And this is the way the data set is and the way you query. And my advice is the same for partitioning in general, and which is the same as when we say in our lingo, when you create the hypertables, which are the dimensions. This should always be related to your workload, to your queries. So how you query the data is very important as well on what you use there to group.
Does this also mean that there's implicitly an upper limit? I mean, that means that there's some amount of data that is too much, because the more data you have, also that means the more iterations you have to go through the compression, right?
The more chunks we have, yeah, of course it is. But you know, there is no real limit. But if you could add, I have never tried it. I don't know if you can add 40 segment by columns, but maybe you can. But what's the meaning of that?
I think from a technical point of view, like from implementation, nothing prevents you from doing that. But please don't try.
But there is a great thing for the old timers like me. I remember back in the day of the data warehousing days, mid-90s, we were discussing about, when we first started discussing about the data cube operator and data warehouses, etc., and multiple dimensions. There is this great notion of the dimensionality curse. So as we add dimensions, the space expands so much that then going inside it is very difficult. And there is this very nice way to look at it. So if you think of a two-dimensional space, if you go to the middle of a square and you draw, you know, the cycle, you go at the cycle outside, you will cover like 95% of the square. I don't remember my math now. Maybe it's 95, 97. If you do in the 3 dimensions and you do the same with a sphere inside a cube, you will cover 80%. If you go to 6 or 7 dimensions, you cover less than 15%. And this shows how from a more mathematical point of view, context, how adding more dimensions when you are doing those, chunks, creates huge problems, which is also the problem because in reality, in databases, we want to go inside those spaces and search. So if you overexpand it, it's a problem. But yeah, this is it. Any other questions? Any other thoughts?
Could I just add one more question regarding this? So I've created a table, just kind of a test demonstrator use case that I've been running now for a few months, and we have, let's say, 3 months of data. It's like never mind. So, but I added a compression policy which did not have a segment by for some reasons, which I brought up before. So what's the process of changing that? Do I need to kind of uncompress everything and then add a new policy with the alter table, etc., or how do you go by to do that?
Yeah, you have to decompress everything. It's not on the policy, it's on the hypertable. So when you set you enable compression, you set the compression settings. So unfortunately, it's not on the policy. I mean that it's very easy to drop and recreate the policy. The problem here is that at the hypertable level, when you set up a compression, you set the compression in a way that it's not very fitting for your use case. We know this is one of the top problems that's on my mind right now with my teams, because we would love to find ways to make those configuration changes easier. It's very difficult because it's at the file system level, but we're thinking about ways. At the moment, what you have to do is decompress everything and re-enable compression with the correct settings. There is no other way around this at the moment. And because, this is a property of the hypertable. It's not a property of anything else. We are going to run a few initial investigations, research, R&D project during the following months to check what can we do about this, because this is a huge pain for a lot of Timescale users right now. So if you do it wrong, you have to decompress and recompress. I know that, of course, a lot of people will say, yeah, this is how compression works, but we are thinking about ways to make it better. No promises, but this is top of mind, at least for me.
Okay, that's all right for me. So thanks for the answer. Yeah.
Thank you.
Yeah.
Any other questions? I will take that as a no. So I will go back to my TLDR, which is longer than the rest of the presentation. And yeah, so what's the problem with segment by? So you should always filter when you update now with mutable compression. You should always filter using at least the segment by together with the time dimension. You need to filter by the time dimension. Databases, us included, are not smart. The planner is the process that takes the query and tries to understand where to look into. So you need to always include the time filter, as we do on the other queries, because it helps us do what we call chunk exclusion, partition pruning in the PostgreSQL lingo. So it allows us to know where to look at. But you also need to add the segment by after we find the chunk. We can use those time ranges, both internally inside the compressed chunk. As I showed you, it is uncompressed. If I go very back, here it is. So we use it here to find the proper ones if your time range is small enough. And also the segment by, because it allows us to only exclude and find only the things that you need to. And why I'm saying this, because we have to decompress everything that is relevant. If you don't do that, you will decompress too many things. And what we don't want to happen is the update table set value equals on. I know this is very expensive. Everybody knows that it's expensive. But if you do it in a query, select from table where, without a where, the worst thing that can happen is that you will go in and you will run a query over a terabyte of data if your table is a terabyte. Here, it means that we will have to decompress that 1 terabyte to 10 terabytes. So there is some need of an extra care here. We have some internal discussion, and this is a very interesting discussion we have. We care about that stuff because we're building a database. Maybe others don't care about it. It's about whether we should stop you from doing this. So if you think about it, SQL and relational databases, we don't stop you from doing things. We don't stop you from running a delete from table. So in a similar manner, there are two camps here where we say, why, if we don't stop users from doing a delete from table, why stop them doing an update table without a where clause and decompress everything? But maybe on the other side, this feels like maybe it could cause problems to someone that is not careful enough. So maybe we can add at some point a 𝗥 that will allow you to error out if you try to decompress more than 20%. This is just a random idea. In reality, I'm on the camp of not being paternalistic, but we are still discussing this. I would love your thoughts on this if you have any thoughts. But in general, we don't want this to happen because we are going to decompress everything. Please be careful. At the moment, I'm not going to stop you. Maybe in the future, we're going to allow you to have a configuration to stop yourselves. So why is everything that I just mentioned about the segment by being even more important during mutable compression is that the granularity of operations right now, and we're working to change that granularity, is at the segment group level. So whenever we do operations, we do at the segment by group. So we update and we change things and we compress things with the same segment by. So for example, if I give a very quick example, if you want to update, you run this statement where you update the status where device ID equals 1, for example, and only this tuple, and there are some additional filters here, only this tuple should be updated. We will decompress this record, we will update this tuple, but then in order to recompress, we will decompress this one as well. which has the same segment bound. It will happen later on, but we have to decompress because at the moment, because after the updates or the deletes, you may have inconsistencies or less data. At the moment, we decompress everything that has device ID equals A inside this chunk, and then recompress everything together. So that's why it's very important to understand that's the granularity now. We are working to also use the order by and some other things while doing so that we decompress as few things as possible. And because that sounds like oh my God, you're decompressing too many things, we may be decompressing a lot, but not in real time. So when the update comes, what we decompress is only the affected records, the affected compressed tables. So in this case, we only decompress this one in order to do what we need to do. But during the recompression, just before we recompress everything, for a single moment in time, we decompress everything else as well and recompress everything together. And this is true for all DML operations, update, delete, and also for constraint setting during instance. So if you do an on-conflict do something, we need to decompress everything inside those segment buys so that we can check for those uniqueness or whatever before and after. Unique constraints, this is a big one. We introduced them now. You can have unique constraints on compressed chunk. We will not have them while also doing inserts before. Why is this important? It's important because it enables some conflict clauses. On-conflict clauses are very important for upserts, but are also important for on-conflict do nothing, which means a lot of times we don't set our pipelines perfectly. We don't have, for example, jobs that sometimes jobs that send the same data twice. That's where on-conflict do nothing comes in. There are other use cases. On-conflict do update is also important for other use cases. So with this update, we also support those clauses. The thing here at the moment is in order to enable those unique constraints, you have to, if you already have a compressed hypertable, you have to decompress it first. And why is that? Because you have to add, we have to add a unique constraint. We cannot check for uniqueness if we don't decompress everything. So we need to decompress, add the unique constraint so that we know that there are no duplicates, and then recompress, and then we are okay. Because every time we do something new, we only decompress the relevant parts and check only inside there for the uniqueness, but we know that the rest of the compressed hypertable is consistent. So this is something that is very difficult to change it for us. I'm not sure if we will ever be able to enable those unique constraints without decompressing. For sure, at the moment, it's like that. If you want to enable unique constraints for existing hypertables, you have to decompress them and enable the unique constraint and then recompress. Backfilling, what are the best practices? Is it okay to backfill, etc., etc., etc.? The limiting factor is the availability of space for the decompression to take place. If you have enough space, there is no reason to worry about it. So if you have a small table and you have a lot of space or whatever, there is nothing that should stop you from not thinking about it. But if space is a limiting factor, for example, you're in a 4 terabyte disk and you have a 2 terabytes compressed, which will go to 15 terabytes uncompressed, you have to be a bit careful. And in this case, you want to be a little bit more conscious of how to do things. So for most use cases, you should not worry about it. For sure, if you have that random updates, it should be okay. For backfilling, the only big limiting factor is the space. There is always, as it was before, manually optimizing those backfill queries and doing it through a script it will be beneficial, of course. So going one after the other, decompressing and recompressing as we were doing up to now. This is just for optimizations. If space is not a limiting factor, you should not worry about this, in my opinion at least. But if you worry about this, I guess that you will know how to deal with it. Think about it. Just create a script to go in order, and remember the segment by and the order by, go on that order, so that you have the most gains. Performance considerations issues. During updates deletes, we have to decompress. There is a small hit that you will take. If the updates are not a lot, it should not be even noticeable, but there will be a hit. If you have if you were run a transactional database over Timescale, maybe that will be, you will not want the transactional table which will have a lot of updates, let's say 40 updates per record, to be compressed. But for everything else, it should be okay. Same for the on-conflict do something clauses. We have to decompress during compression constraint checking. So there is this overhead, but it should not be huge. Of course, inserts, as I told you already, are way faster. Issues, to be careful with jobs. Recompression is done in background jobs. Be careful of your background workers. Set your background workers correctly. If the jobs cannot run, the policies cannot run, we will never be able to recompress and reclaim space. But I think if workers cannot work, most of the things, the valuable things that we offer, compression, continuous aggregate refreshing, and more, will not work either way. So you should always have a good hygiene on your workers. Logs, there is some log contention, not a lot of new things here. We will add this on the documentation. This is something we are also working on, removing as many logging issues as possible as a follow-up. This is, but more or less, not a lot of things are changing here. There are some additional logs that we have to take to synchronize while update or inserting. Some of those are relevant for MVCC, and some others are relevant to make sure that everything is not is okay for consistency only. Yeah, the same things that are true for other types of DML operations are more or less here as well, with some additional stuff. That's it. Limitations. As I told you, the big limitation today is that what I showed you on segment by group level of granularity. We are actively working today on it. Let's see when it can be released. We're very careful with any update on compression. This is one of the most used features, and we are very careful when we are introducing new features, even small updates like this one to compression. So at some point we will release it after we fully test it for a while. So we will change the granularity from the segment by group to have even larger granularity, higher granularity. And this is the fast follow, is to use the order by metadata as well. That's it. I did not expect us to get here. I thought that we will stop before this lecture. So I don't know if you have any questions or anything, any comments, any.
I have a quick question about the recompressing from the staging area. When it does the recompress from the data that's moving from the staging area back into the main table, does it recompress the entire chunk, or does it recompress just the staging area data and or its related segment by? Yeah,
only the related segment bytes, which is already too much for us. That's why I'm going to stay saying that we want to do even less than that. So it may not be too many, depending on the granularity of your segment by. It may be, but we only decompress the relevant, compressed chunks, tuples. So we don't block you while doing the update. The operation will return as fast as possible with the overhead of decompressing. But at the step when we're ready to recompress, we will also touch some of the additional tuples that are with a similar segment by. Not the whole chunk for sure. And as long as you have a segment by, so for Daniel's use case where he does not have a segment by, that means that we will have to recompress the whole chunk, which is not fun.
Yeah,
But it's also maybe it's fun because it happens in the background. But you know, and I'm going to say again, people inside Timescale are making fun of me. They want to print T-shirts. Think about your segment by, because I have said this so many times in internal meetings.
Yeah, no, definitely message received on that one. I think it's definitely a pro tip of the day. Another thing I'm curious about the recompress is, say for example, in this scenario where, you know, a backfill goes through and it's essentially, you know, doing an insert or an upsert or otherwise mutating. Say for example, like 30 days worth of, you know, of data, and each day is a chunk. Does the recompress, what is the logic behind that? Will it attempt to do as many recompressions in parallel, or does it sequentially start at a certain chunk and just work its way through? I'm just curious, because obviously, because I think you mentioned that you can't really control the recompress. I'm just curious, underneath the hood, what's the logic that's powering the recompress logic?
Yeah, at the moment we are doing a sequential. Most of our jobs are sequential. This is something we want to work on as well. This is a difficult problem due to logging, but at the moment we don't even do a lot of parallel stuff because logging is an issue in general. This is also top of mind for us. It's very relevant for compression. It's even more relevant for continuous aggregate refresh because there are other things that we want to parallelize. In general, our policies are sequential. Each policy has its own job. But inside that policy, this specific compressed table, things will run sequentially. So it may take some time or it may not. This is the part where I said we had a lot of power behind the scenes in Timescale. You can go find a job for that compression policy and fine-tune it to run every 10 minutes if you want. By default, for everyone to know, the default rescheduling period, scheduling interval we call it, is half of whatever you have set the compression policy. So if you have set it to do things after 7 days, it will run every 3.5 days. This may be okay, or may not be okay depending on the number of updates. So you can tune it and bring it down. I think that I will not overdo it. But at the same time, there is no cost at running that job if you don't have anything to compress.
Yeah, of course. Yeah,
it's smart. It will not do anything there.
Yeah.
Let me open the comments as well. Yeah. Anything else?
Yeah, just another point. Just wanted to clarify a point that I think you mentioned on one of the slides in terms of supporting upserts and with the on conflict clause. It mentioned that you have to decompress to essentially check the constraint. I'm assuming that you don't have to decompress the entire chunk just to check the constraint. The constraint is checked after, once the constraint has been triggered, and then in order to support the upsert. Or do you have to decompress the chunk to say whether or not the on conflict clause is going to be triggered first?
You have to decompress everything that is relevant because we have to use the unique constraint on the uncompressed table. So everything that is relevant has to be decompressed. This is the truth. That's why I'm going back again to. So the granularity is at that level as well. We have to decompress the relevant stuff.
Okay, and
so if that granularity is with a minimum of the segment by again. At the moment, the minimum you can go is the segment by group level, you know. But we're going to work. If we can go further down, we will go in the next iterations, next releases.
That makes sense. So yeah, the whole chunk isn't being decompressed. It's just essentially the segment by compressed area.
Yeah, the relevant parts. So you know, because on instance using a unique, we cannot check for uniqueness, for example, if you insert without decompressing. So you have to do some break stuff.
That makes sense. Yeah.
And then also, if your uniqueness constraint is on the segment by or on a column that is on the segment by, that things will be way faster for us because it's already uncompressed as well.
Yeah, that makes sense. And I assume, like in the scenarios where an upsert doesn't result in a updated row, but a new row, and it pushes it over the 1,000 record or row batch, I assume it then decompresses the subsequent segment by, and then essentially recompresses that with the new inserted data.
Yeah, unfortunately.
Okay. Yeah.
Yeah.
Well,
But
then it goes.
this is so complicated. Yes, it's true, but at the moment I cannot even recall exactly the pop that we do. But what you said is true in theory.
Yeah,
I
and then
don't remember exactly.
It goes back to essentially what you keep saying is about having intelligent second segment by fields defined, because that would significantly help, I think, at least limit the amount of data that needs to be decompressed and recompressed.
Yeah.
Cool.
Yeah. And we're working a lot on, I'm going to give some insights here. I know that I like to be transparent with our planning. Top priority, the granularity. Decompress, compress, do operations with as few tuples as possible. Locking, we want to remove as many locking issues as possible. Locks, not do it locks, just locks, are the enemy of production systems. We want you won't hit those, but if you start hitting those, it's a huge problem for production databases. So we are trying our best, and this is in general something we have in mind both there and also for hypertables. And then the long term, we have some optimizations that we keep doing on performance optimizations on executing on compression. We will never stop working on compression. It's one of our most important things, whatever else we do. And then there is the open-ended R&D project that we are starting. We never know what we are going to do on whether we can have, configurable segments for compression per chunk or something, being able to not take the, go through the pain of decompressing and recompressing again.
Cool. Yeah, no, that's fantastic to hear. Yeah, and also just from myself too as well. Thanks very much for this session. It's been very informative. Thank you.
Thank you. Any other question?
I have a little question. I can think of use cases where I would like to view the compressed chunks as immutable, in the sense that, okay, we have a data stream, and the time, if you were to get a timestamp that would mutate a compressed chunk, that would be something that you don't want, because that's an error in the data or data quality issues or whatever. Is there a way to handle that somehow to block mutation of the chunks, and if there is, can you kind of unlock that feature in a sense, because sometimes you might want to backfill data, but in a manual fashion? You see my question?
So can you please, you're not the first one that mentions this to me. Internally, we're calling it freezing chunks, because if you can freeze a chunk so that you switch it to being immutable, if you could be so kind to add a feature request for that, so that other people can add their thoughts and vote. We are still an open source. We are working as an open project here. If this is a request for a lot of people, we could check it out. It could be doable.
Sure.
We are doing that with data tiering, for example. This is a feature we have on Timescale Cloud, where we freeze chunks before we move them to S3, because this is a way more involved process. So we first freeze them and then asynchronously compress them and move them to S3. So on that feature, we do that. We don't have it for other features. There is a debate internally where people are like, why do that? So I would love if you can add it as a feature request and also provide us with your use case exactly. It would be very beneficial. And also other Timescale users will be able to upvote it, etc. Which is also a great signal for us.
Yeah, we'll do that.
Yeah, I face the same issue. We ingest data in real time, and then we do bulk loading of past data. And for the real time stuff, we just put a filter that we've coded up that if we get a timestamp that is out of range, and for us, it's quite simple to figure out if it's out of range, we just ignore that one sample.
Yeah.
Right.
So there is always a trick. You can take a lock on the table, select right or something. But my DBRE friends will kill me if they hear that I suggest this, because so you will do that for a while, but you cannot do it forever. You know, and you don't want to take your statement timeouts and transaction timeouts to be infinite. There is very bad hygiene for the database. But yeah.
Yanis, one last question for you. Is there any plans to make compression enabled by default without any configuration, like zero planning?
Who asked this question? Is it your question or other people's?
Yeah, no, that's my question. Like, just for the sake of like, I just want to use the best of Timescale and I need to enable it, right?
He just wants to mock you.
You want to mock me because this is the vision. This is the vision for, but it's a few years vision. This is the dream. If we could go there, I truly believe that not all users, not everyone will want compression by default. There are all those use cases. There are all those things. For example, I'm one of those people that I don't like people touching my data.
Yeah,
you know.
Yeah.
So if somebody will touch my tables and maybe something for me by default, I will be very offended. But for a lot of use cases, that will be very beneficial. We have a long-term vision. I have that vision. So, but we are discussing it internally as well. This is a multi-step thing. We have to think about how can we offer, first of all, smart suggestions for segment bias, for example, for compression, and test them out. See, are those useful for the community? Are those useful for our users? And learn from that, iterate on that. Once we get to a point where our suggestions are good enough, we can switch them somehow to smart defaults, but still you enable compression, but we have them as smart defaults. If you don't set up a segment bias, we trust ourselves that we are not going to do any harm, at least. So our smart defaults will be better, at least, than doing nothing. So this is step 2. Step 3 will be to identify some segments, some types of workloads. I don't know. I don't even know what to do in step 3, and go to compression by default. But even I think if we can get to step 2, it will be amazing. I want to iterate on the Timescale cloud. We have this the console, database console. We have this compression wizard, compression explorer that we would love to enable for all users so that they can experiment, at least start introducing some suggestions. Maybe we will do it there, maybe we'll do it some other places. Everything that I'm saying now is not a promise. I'm just brainstorming live with you, all of you. Now that and the internet, hi mom. But yeah.
So if everything works out, you're moving in with 𝗥𝗲𝗃𝗃 in paradise.
It's like, you know, as all good plans, list of plans should be step 1, step 2, step 3, step 4, profit, something like that. The profit part for me is to go to paradise. Yeah, so we are thinking about this. I agree. But yeah, it's far, far away. I don't know if we ever manage to give smart default suggestions to all of our users, to the community, or even smart defaults for new and then smart defaults. I will be living the dream. I will be so happy.
Brilliant.
Very good, very good. So we are running out of time. I think we can follow up with the next questions asynchronous, because like Yanis is so cool. We can spend 1 hour here with him or more. So thank you very much, Al. And Yanis, if you want to leave any extra research in the channel, we can also be following up later. And we are going to also upload these if anyone would like to fall back and see it again. So yeah, thanks again. Our next meeting is on July 19th. So if you want to come again to office hours, everybody is very welcome. We also announced this forum blog post just saying that if you have any topics that you want to bring in this session, in the next session, just you can leave a comment there or reach out in direct message. and then we can try to follow up and discuss your topic in the session. And we are also trying to invite more people to come to bring their use case and other cool stuff that we can be mixing here in the office hours.
Great.
Okay.
Thank you for all the great questions. And whenever you have any suggestions, please add them as feature requests, ping us on our public Slack or our forum. We really love the feedback.
Thanks a lot. Very enlightening hour for me.
Indeed, yes. Thank you very much. Appreciate it.
All right.
Thank you.
Thank you guys for joining.
All right.
Bye.